Welcome. Good morning, good afternoon, and good evening to everyone. Thank you for joining our webinar today. In today's presentation, we will hear from Lumo on how they revolutionized smart agriculture to save growers time, money, and water by leveraging MQTT and HiveMQ. Before we get started, a couple of logistics. At the bottom of your screen, you should see the Zoom toolbar. There you can find the controls such as the chat, Q&A, and more. So if you have any questions throughout the presentation for our speakers, please submit them using the Q&A section. For discussion, please use the chat. And if you're experiencing any problems, please send me a direct message. I'm here to assist you. We will be recording this session today, and the recording will be sent out to everyone following the webinar. And now I am going to pass things over to our HiveMQ speaker, Mark Herring, to kick things off. Thank you for joining us, and I hope you enjoyed the session.
Thank you, Nadelia, and super excited to be with you here today, and even more excited about my guest, Cihan, who we go back a little bit. We've been at a couple of different companies work with together, and Cihan's going to share some of his experiences. But just to set the context of what we're trying to do here is Cihan's got a wealth of information, and yeah, I'm hoping to extract some of that and have some fun along the way. But it's going to get little technical, hopefully, and down into the weeds of why things like Kafka, why things like MQTT. But before we get that, maybe I'll just punt it over to you, Cihan, to do a little bit of introduction about yourself and about Lumo. What does Lumo do?
Thanks, Mark, and thanks everybody for attending. My name is Cihan. I'm the CTO at Lumo. I've been around for a while doing building technology startups for about a little bit over 2 decades. I believe about 25 years now. I squeezed a few water-based water protection startups, and Lumo is one of them. A few AI companies, and a few fintech, and a few, I think, small business HR template sort of companies. But I like IoT. That's my expertise mostly. And my sub-expertise is about water. I like to build sustainability startups. So again, thanks for having me. I'm really looking forward to have a fun and technical conversations. So for the participants, please ask the most difficult questions you can ever imagine.
Love it. So Cihan, do you want to sort of, I know you had a sort of slide deck to go a little bit about Lumo and sort of background there. Do you want to walk through that?
Yeah, sure. I guess it's visible now.
Yes, it's perfect.
So we are Lumo. We are a California-based smart irrigation technology company. We are building products for farmers who actually grow our most pressure, our food to sustain this world and the humanity. And our product saves tremendous amount of time, money, and water for them. We have a mission. Like I said, we want to make sure our next generations have water and food security. And obviously, our objective is to be the #1 irrigation management system and the large system of the record for fresh water use globally. I'll put this into context. So basically, again, this is me. This is my background. But this is the product we build. We are building an integrated cloud management platform to make irrigation extremely efficient and sustainable. We do it by actually building a smart valve, modernizing an infrastructure that this generation ignored quite a bit. And by doing that, actually, we save people quite a bit of time. So a lot of manual irrigation labor is gone, and a lot of cost savings come into play. So you would be surprised, Mark, actually, how we grow our food right now. Like my generation that grow in city probably think that food grows in the supermarkets because it's very easy for us. We just go swipe our card and we our fresh produce. There's a lot of operational complexity, like almost similar to building a jet plane, like a lot of supply chain, a lot of operations. So we like to modernize this, and we are one of the actually let's call it the second generation wave, because the first generation wave of products tried this with cables, controllers, with a lot of actually complexity. But with the modernization of the technology, now we are tapping into that modernization to build really cool products. I'll talk a little bit about the product later, but Our product is unique. We build our own hardware, own software. So basically, this is a smart valve. You buy a bunch of them. You replace your valve with our valves. They are connected to each other. They are battery operated, solar powered. So we are solving problems like you don't have electricity in your farm, no problem. And you don't have to wire cables because it gets into your way. Like I said, there's a lot of operational complexity, like driving tractors and all sort of things. No cabling, no electricity needed. These guys have offline support, and we monitor water flow quite a bit. We capture a lot of data. So basically, it's a decision maker product. You can effectively apply and deploy water, but also you can collect all that data, like you see in an iPhone screenshot, to make decisions. So it's a lot of cool complexity, and I'm hoping to talk about that in the technical section.
Love it. So, Cihan, let me ask a quick question on how do people? I'm a farmer, not really, but let's pretend. How do I know I have this problem?
So you know it. First of all, most of the farmers are generational farmers. We have a customer that is actually 23rd generation wine maker. So they were making wine for Medici families, maybe even for Jesus. But basically, let's assume you're the first. You just bought a farm, and you're first generation. That complexity includes nurturing the soil, planting, whatever you're growing. Let's say in this case, wine. Most of our right now we pretty much focus in California, wine growers. You have to deal with a lot of fertilizers. Well, obviously, plants grow with water. You have to deal with a lot of pumps and plumbing and all sort of things. Well, who's going to water your plants? You have to find labor. And that labor, you're not going to hire a bunch of, I would say, PhD students to go turn those valves manually for you in the middle of the day or the night. So number one problem here is actually the labor shortage, especially in California. Also, again, this is difficult. This is a difficult job. You either do it at night or you do it under 120 degrees in the middle of the day. It's number one. You can't find that labor. And if you find, you're relying on manual labor to deploy water to your plants. Now, if you're in high value crops, like let's say wine or strawberry, you want precision. You want to say, hey, I want my, let's say, this block, this much acre to be watered by this much water. Like an example would be, hey, I want to deploy 10,000 gallon to my let's say Chardonnay, and I want to deploy 5,000. Or you can say time-based, right? Hey, from 2 a.m. to 6 a.m., I want to water my plants. So you're going to send somebody at 2 a.m. First of all, you can't find that labor, but if you find, you have to pay overtime. And is it a sustainable labor cost? It's actually not. So we are solving all those problems on the time and obviously money saving. But the third one is obviously one of the most important one. When you cannot control, when you don't have the tools to deploy how much water, as a farmer, you tend to just use as much water as possible. You don't want to underwater. People flood their farms, they redirect rivers, or they pull like insane amount of water from underground reserves. Well, that water, fresh water, is limited. If we keep doing that, our probably grandkids won't have any proper underground water. So we solve all those problems. In fact, the company, our CEO, actually had this problem. He's a tech guy. He bought a farm. He was doing this, and he quickly realized that, okay, nobody does this. So the problem is actually very common. People get this. The challenge here is not that people do or don't realize the challenges. The problem had been so far, they didn't have trust the technology. Because so far, again, the first generation of products to solve this problem failed. It failed because, again, they approach to the problem from a technology standpoint. Like there was this disconnect. You can't just take technology and apply to sometimes a real problem. You have to get the context. You have to ask the question, hey, what's the problem? What's the challenge? Then you go develop. that's actually our approach, and we take pride with this approach.
Interesting. Very, very interesting. So take a step back, maybe just before Lumo came along, like what, and I know you sort of had your slide of so your backgrounds, but what excited you about IoT? Like why IoT? And maybe we start the journey there. You know, obviously Lumo's we are now, but like the journey started before.
Yeah. I'm doing IoT for about a decade, 10 years. So actually my background is industrial engineering, but I was always a computer guy. I was fascinated with data. I don't have kids, but if I have a kid, probably the first one would be named data. The second one would be efficiency. That's a negotiation with my wife at this point going on.
Good luck on that one. Yeah, we'll take a poll afterwards on that. Yeah.
I'm coming from like an engineering background, and funny enough, my actually grandparents were farmers, and my dad used to build like hardware like for Turkish military, like big components and military ships and everything. So I grew up playing with like mechanical parts, putting those together. Believe it or not, I used to fix our TV when I was 11 years old. I could manage to fix a lot of things. So I went into software, industrial engineering background. I learned how to make things efficient, how to put things together. And I spent about 10 years in software building a lot of actually, I would say, SaaS products. Started with travel industry, modernized it quite a bit. And then I got the startup bug, co-founded a few one, like CRMs, ERPs, integrations. But the one that I enjoyed the most after I moved to States in 2010 was this tiny startup where we actually help small businesses. Basically, we were helping mom and pop shops get their licenses with like 2 clicks, preparing all their forms.
Sure.
Or let's say an immigrant person will apply for a green card, for example. Instead of paying a lawyer $5,000, they would just come to our product, subscribe, and get all those forms, provide all the information at this clean PDF, and like done. So I really got this mission of helping people as much as possible. And then that company was acquired by Intuit. Intuit is a big, obviously, corporation. Sure. I worked at QuickBooks product quite a bit. And then my CTO at that time, at that startup, actually recommended me to one of his friends. That person, Henry, one of our co-founders, actually Lumo, we still work together. He's the inventor of my first IoT startup, was called Flow Technologies. It was a water monitoring and conservation device. Basically, I'm sure audience is familiar with Google Nest, or like a car alarm. It was like a water alarm. So when I met Henry, he's an extremely knowledgeable gentleman in his late 70s, extremely like, I would say, sharp person. When he showed me his invention, I was like, okay, that's it. Like, this is the thing that I want to work. By the way, this is 2015, late 2015. This notion of IoT is not that common. Technical people, let me say this. There's no AWS IoT. There's no, like, IoT probably is used by like 5 to 10 people in the world. And I think people that knew MQTT was maybe like 10,000. And I would say like 99% of them probably were IBM people. So I love the idea of actually building a product and being the first person. I was the first hired person there. Henry and Henry's son were the co-founders. I just got that bug, and immediately I'm like, okay, I'm tired of, again, no disrespect to obviously corporation, but I'm tired of making corporations more rich. I didn't love the fact that, people in the United States had to pay even more money to pay their taxes. So I'm doing like a flip. And honestly, Henry explained that to me. Coincidentally, I'm a backpacker by heart. 2 weeks before I joined Flow, I was walking in High Sierra, California, on a dry lake bed, actually, sand up to my knees, the famous John Muir Trail. Anyway, so everything aligned, universe calling me. And fun fact, Cihan means universe in Turkish. So I took it as a from universe. I joined, and the amount of data and the challenge, the engineering challenges was just fascinating, honestly. Like, I probably learned 5 times more in my last 10 years compared to my first 15 years of career. And for technical people, challenges are the ones that drives us.
Sure.
So
Yeah.
long story short, that was my bug. And then Flow was acquired. And then I just kept going, like AI, IoT, and I think I'm just
So let's, I mean, Flow or even like Lumo, like, I mean, seem similar. Got this remote device. Why MQTT? Because I mean, you mentioned MQTT in passing, but obviously there's other tech out there. So let's start there with why MQTT? Why did you? And I assume that's what we are still today. But yeah, why? Let's start there.
Great question. So for Flow use case, being real time was number one requirement. We did. I mean, I like this statement: principle driven development. I don't even know if it's a thing. I just use it. PDD. When we sat down with Flow people, we said this product will protect people even from a drip a minute. Everything has to be real time. So when I was very comfortable with HTTP and like response request stuff, I did not know about MQTT when we were having this conversation. So I started to look around. Obviously, number one requirement was being like real time. Now the notion of real time obviously is like, to me, it's like 100 millisecond or less.
Yeah.
So we chose MQTT because of the low latency. I don't think there is any protocol, again, unless it was developed, and I'm not sure. Nothing can beat MQTT in terms of low latency and responsiveness, and bidirectional. So it's in my opinion, it was the right protocol, and it was proven immediately. We had 2 competitors at Flow, and we were the first acquired one. We actually got acquired in about like 3 years. And I always say that the marketing team loved it. We dunked on our competitors in our demos in responsiveness, and our CEO, super smart guy, former CEO, he said it very clearly. If I want to turn off my water, and if I click on my mobile app, I'm gonna see that valve turning and closing it. So in under like 200, 300 milliseconds, less than half a second, you could actually protect your home. That was why. Also, not to mention that these devices are very like low power. They are not like this random, like high GPU computers. The amount of data, the processing data, they all come to play and not to mention the security, obviously. MQTT protocol is just like a sweet protocol, and in my opinion, it's highly optimized for these kind of cases.
Interesting. But and then I know you. Oh, sorry. Go ahead.
No, I would say 50% of the decision was like nothing came close to real time.
Because I was going to ask, because Lumo seemed even more complex in terms of energy consumption, and you said there's batteries on here or solar. How does MQTT fit into that? And tell us a little bit more of the pain of, I guess, the pain that you also encountered at Lumo, where things are a little further from the house, right? So
correct. There are pros and cons, but Lumo product from the engineering standpoint is actually a much more difficult product. Why? Flow product, the hardware was a little bit better. Also, it was a consumer product. Lumo, this one is more like a B2B use case. Also, it's sitting outside. So Lumo products are sitting in farms under, sometimes like 130 Fahrenheit or 60 Celsius. It snows on them, it hails on them. It's like, leave your computer outside for 24 hours and you will see actually like what happens, right? There is dust, there is mud, there is all sort of things. Also, one of the main things is power budget. Flow was powered, we could like wire electricity. It was constant power in this case. Obviously, technical people understand this. There's no power, there's nothing. So our current product is obviously by design, battery operated and solar charged. This number one pain point in farming is in most of the farms, electricity is either far away or it's non-existent. remember, farmers choose their farms very carefully, depending on what they are going to grow. Some people, grow like Pinot Noir, right? They like to go higher, maybe like on the north side. Some people choose differently. The second one, in terms of difficulty, the connectivity. Like I said, farms are far away to city. In certain cases, there's no reception. So how are you going to actually command to say, okay, turn on the water or turn off the water, or how are you going to collect the data? So the second was the connectivity challenges, and the third one, we deploy a mesh product. Those farms can be as big as like hundreds of acres, thousands of acres. So how are you going to cover actually in such a large mesh? So think of your home network, let's say a typical 2,000 square feet home. You want to deploy Wi-Fi routers. The current modern routers, and with their APs, access points, you have to deploy 4 or 5 so they can talk to each other, right? In this case, you're talking about a mile in between. Sometimes you're talking about actually 10 miles. Now, industry solved these challenges with amazing protocols like LoRa, LoRaWAN and different things. But it's not the cookie cutter to say, oh, take LoRa and apply. For those, let me give you a tip for those that are actually willing to do some sort of similar application. Your communication protocol is what makes or breaks you. So a lot of people can say, yeah, but LoRa can go up to 50 miles and kilometers. Yeah, sure, but the bandwidth in LoRa is so low, it's horrendous. Like it's a great application if you measure like this little bit, 1, 0, whatever, every 2 days, 5 weeks, that's fine. But in our case, Lumo is also actually as close to real time as possible. In this application, we are as real time as a minute right now, and we are going to make it much obviously better. So the distance, it was one of the actually most difficult challenges, and these are not just flat places, right? There's water in between, like hilltops, trees. So we had to do a lot of testing, and I'm talking about antenna communication, like penetration depth, battery level, how much actually you need to sleep, because the irrigations don't happen all the time, right? And
interesting.
How much heat. So it's like playing chess at any time. I'm very actually proud of our product, and this is a startup, early stage startup, with a lot of resource constraints. So yeah, like
interesting. So we got a question that came in while we're talking there on your MQTT infrastructure. Are you running that on premise? You're running it as a cloud service, and didn't ask this, and why maybe?
We are running on HiveMQ cloud. You guys actually take care of us at Lumo. Before at Flow, we ran on-prem, and the only reason for that, you guys didn't have a cloud application. So I'm a firm believer of, like I said, principle-driven development. In early stage startups like us, pace is everything. We operate with sense of urgency and go-to-market pace. Usually in startups, people that go to market earlier with a higher quality product wins at the long term. So I wanted to use our limited engineering resources to build our own product versus, maintaining HiveMQ Cloud, Promise, and everything. Like I said, this is a principle. I use managed services on AWS, and I could actually build this product with a handful of engineers. Like right now, we have a little bit more awesome folks, but the original team was about 4 people and me on the engineering side, and we could commercialize this product. And it's because the ROI on the cloud is just insane. And I'm a firm believer of this. I think the times change. There are a lot of amazing experts on infrastructure. I like them to handle this for me. And the second one is peace of mind. I don't have to have an infrastructure engineer, and I don't have to think about, oh my God, like, will my MQTT broker go down at 4 a.m. and set up, international like staff and monitoring? In the first 2 years of startups, I have a lot of problems to deal with and challenges, both technical and, and the mental. It's an emotional roller coaster. So just having that peace of mind actually like affects me positively, like when I face those other challenges too. And like I said, honestly, ROI is probably 50x.
Excellent.
And what I would do on promise, this is my usually, look, architecture is like supporting a football team, like a soccer team. There's no right or wrong. If everything goes well, like we hope, and if we get to a scale that we need to customize things and it's more cost efficient, I would take it on-prem, no problem. So I'm not scared of that. It's just we have to be context aware of where you are as a startup.
Excellent. Another question came in, which I think is relevant here as well. Like, did you consider MQTT SN, sort of for sensor networks, or is MQTT, I don't know, classic?
Yeah, I actually talked to Christian, HiveMQ CEO, about that. By the time you guys were implementing, that's actually something in our queue. We will definitely look into it. It's a good use case for applications like us.
Interesting, very interesting. And then I think the last one on while we're on the MQTT is I think you mentioned 100 millisecond latency and then a minute. So what sort of latency are you getting now in your deployments?
Yeah, we actually are pretty much real time. Okay. So if I wanted to send a command to one of our units, for example, to say, turn on, turn off, or apply the schedule, it's actually real time. When I'm saying a minute, that's our data aggregation point. We collect data every minute. But right now, our latency is under a second. That's not a problem. And even with a few layers, I think you will ask me the question about, what kind of architecture. But let me give you a hint. In my opinion, in IoT, data and data integrity is the most important thing. If you cannot send the data or receive the data, you're just done. Therefore, your first layer in your infrastructure that your sensors connect to is your most, in this case, HiveMQ for us, is the most critical point. If you can get your data to your MQTT broker, the current applications like HiveMQ or your competitors, at least to a point, they are resilient enough. You guys don't lose the data. And then after that, it's obviously some people like to take that data and put into S3, Postgres. I use Kafka as a back burner. What I say is if I can put my data into my Kafka broker, I'm good because I have a lot of resilience and everything. So all those things end to end, from sensors to HiveMQ to Apache Kafka and downstream, right? Data processing, and we use time series databases like Timescale. We're pretty much honestly in seconds. And for our agriculture application, a few seconds actually are nothing. People are used to hours. Right now we're at minutes, so people think this is rocket science. They pretty much love Lumo at this point. Yeah. You can check the logos in our website. We work with some of the largest wine growers in the world right now. Again, that's fantastic. Such a startup.
Yeah. So tell me, so we got the data coming in through MQTT on the cloud. Why Kafka? Why did you put Kafka in there? What's the architectural reason for that?
Yeah, I think this was one of my best decisions as IoT architect, let's say. I've been using Kafka since 2014. Why Kafka? Because I look at data as the sensor data as a stream. Obviously, the most important thing in IoT data is the timestamp and the actual value. In our case, let's say water flow rate. It could be 40 GPM, gallon per minute, timestamp. MQTT brokers are great for real time to take the data, but they are not a traditional queue, or they are not a unlimited resilient queue. So Kafka actually provides. It's not a technically queue. It's a log. It's a committed log. Yeah. It's a very reliable piece of infrastructure that you can push your data, and it provides that peace of mind for you. You can take that data and archive to S3. You can take that data, process in your backend applications and push into your monitoring systems, which we do. Everything I'm saying actually what we do today. You can take it, you can do check data integrity, you can massage the data, you can correct data, and you can put into your timescale or time series database. We use timescale to actually power your applications, in this case, web applications, mobile applications. Also, let's say something happened in your backend or AWS down, let's say. if your data arrives to Kafka, you're going to recover that data. Obviously, you have to configure it properly. In this case, you can set a retention of, let's say, 30 days in your Kafka topics.
Sure.
And let's say your background data stream application, your custom code failed, or your engineer checked the bug, and you have to reprocess everything for the last, let's say, 7 days. No problem. You can just go, change the offset. So it just creates like a back off, sort of like systems. And there's like a lot, if you can design your MQTT Kafka connection properly, you can actually guarantee the data order, which is one of the most important things you need to do. And you can do, deduplication and all sort of things. One of the actually sweet parts, I would say, it's extremely fast for technical people. Don't be scared of Kafka. Now there are managed services, and the producers, consumers, the libraries are so modern right now. And one thing, we use a HiveMQ Kafka extension. Honestly, it's some of the best things in the world, because I actually wrote that extension myself in 2016. And your CEO knows this was my first request to HiveMQ. We wrote it.
Yeah.
It took a lot of engineering time to get it right. Right now, you just say, hey, change, if data comes to this MQTT topic, just send it to this topic. It's not like a configuration of topics. I know that pain, so I'm smiling because it's probably saved me like 6 months. And one thing you can do with Kafka, or anything, look, it doesn't have to be Kafka. It could be RabbitMQ, it could be SQS,
Kinesis,
but Kinesis, whatever.
Yeah.
Which I definitely don't recommend Kinesis, but people use it for whatever reason. One thing, in my opinion, you should do. Kafka has a very powerful ecosystem. When I was using it the first years, there was no Kafka Connect or nothing. Right now, you can use Kafka Connect. You can put a connector there, like a sync, Kafka S3 sync, and you're going to keep your data science team very happy. What you can do, your data science will say, hey, don't change the data, don't massage the data, just give me whatever comes from the sensors, because they are going to do algorithms, they are going to do anomaly detection, right? But your application, if you get like a random incorrect reading, your sensor broke, you cannot show it to your customer. So you can just basically plug in Kafka Connect S3 sync and deploy a configuration. In about 5 minutes, you're going to start archiving your data to S3 as a cold archive, right? In 5 minutes, you can configure, let's say, Kafka Connect Elastic Search sync, and you can immediately actually push it to Elasticsearch or whatever, like timescale for monitoring and for data. I like that kind of, like I said, plug and play architecture. And I like to focus on my own logic, building on product. And I almost think like it's a waste of our brains to redo things over and over and over. Again, that S3 plugin is available for 5 years. That Kafka Connect is a mature thing. And not to mention, you can run a lot of like logic. You can put Apache Flink, tap into Kafka. Just be careful. I made a mistake when I used this. Again, very rookie mistake 10 years ago. Make sure to use your partition keys properly. So, the data order is guaranteed. Like last thing you want is, you have to reorder all those things at your consumers.
Yeah.
That's a lot of fun. Your customers will see like, let's say your water pressure is going up. Instead of 40, 41, 42, they will see 40, 42, 41. Those are rookie mistakes that we have done. now I'm like almost it's cringy, but yeah, we have done all those things.
Well, that's why we have you, because people don't have to make the same rookie mistakes.
Yeah. Oh, and then one more rookie mistake. I'm sure nobody will do among attendees, but just make sure your MQTT client IDs are unique. I've seen this in 2 different IoT startups. One of them was me 10 years ago, and one of them was one that I was consulting. All of a sudden, like clients lose their like visibility. It may actually lead to data loss. I know it's the most basic thing, but just make sure your MQTT, subscribers, publishers, just use unique IDs, either their MAC ID combined with CPU ID or something like that. Trust me, a lot of people just ignore that.
Okay, so we've gone from the MQTT to the cloud, right? Cloud into Kafka. You mentioned going into time series database, timescale. How long is sort of you keeping historical data for, right? Because and then you also talked about sort of cold archive, but yeah, let's talk about sort of length of keeping that data.
It's definitely based on your requirements. So cold archive, infinite. Obviously, you have to retain your archive. In our use case, we keep it for 6 months in time scale. At Flow, it was actually much shorter, 30 days, because the whole notion of time series is data aggregations. So your data is usually at a very high frequency. Like it could be 1,000 reading per second. It could be a reading per second. Everyone's use case is different. But at Flow, we were doing 1,000 readings per second. We use different databases. We use timescale also. Your retention should be determined by your product use case. I highly recommend keeping it short. In timescale Notion, they do a lot of cool stuff. I know the team actually behind it, and honestly, they're awesome people. If you learn how to use the database, you can use their chunks, and you can keep your database extremely efficient. You're going to pay less storage fee. Your compute obviously doesn't have you don't have to scale to massive clusters, but most importantly, your queries will be extremely efficient. Like, again, I'm coming back to this principle-driven development. My third principle is data is great, but data is bad. So the data you need is great. Everything has to be data-driven, but stale data is worse. That's going to just like kill you. I made that mistake too. In another database, we didn't clean up our data for about 2.5 years.
And
it was a cloud product. I mean, InfluxDB, as I'll just say it, it's not their fault. And we just kept upgrading the CPU and the storage. And they came back to us and say, if you don't clean up your data, the queries are just becoming massive. CPU time are becoming massive. They said, we cannot serve you. We have to let you go. And that was like, okay, more data is not good. And it was so unnecessary because we had the cold storage anyways. A lot of startup people will ignore that, including myself. Because, right, you don't have enough data. You don't care. It's a technical debt. Anybody doing this, don't cross 6 months. Just go set up a cleanup policy or something. Also, don't wait for your cold storage. Honestly, set it up day first. But otherwise, you have to migrate data, right? You have to always keep it for 6 months. Don't set yourself for failure. These are hard-learned lessons, in my opinion.
And then, I mean, obviously today with AI or ML, clearly we're wanting to make better decisions on the data. I'm sure Lumo's got the same problem going, hey, it's great that the farmer thinks about the stuff, but hopefully the computer can do some thinking. What's your thoughts on that and how you're approaching that side of the world?
Yeah, great question. We actually use quite a bit of, I would say, decision-making to help people. I wouldn't say we apply typical AI. We are going towards there, but we have a few features already in production, commercial. One of them is Flow Vision. Basically, right now, people come and create their schedules, right? Hey, I want to deploy water from 2 a.m. to 4 a.m. Now we are actually telling them, hey, this is what you intended, but this is what happened. And we are just showing them recommendations. This is your theoretical rate, but this is the reality. So we are going towards more like creating effective schedules for them. So for context, effective schedule means, determining how much water they need. Is monitoring it, pushing irrigations to night. Why? Because at night, evaporation is less, right? And making sure actually their combined schedules are not conflicting with each other. So we are trying to find the most optimum, savings for them. Also, you're living in California, so energy costs are different. Peak hours, off-peak hours, and some of the irrigation can be moved to off-peak hours to reduce the energy consumption. Now, people can say, wait, how do you spend energy? most of the people run those massive pumps to pull water, either from their, lakes, river, underground reserves. It's a lot of obviously carbon production, and it's a lot of energy. So as a farmer, you keep an eye on those costs. So this is where we are working. And we got the execution, we can deploy the water. Now we are trying to help them with integrations and those decision making, like what the schedule should be and how you can utilize water in the most effective way. In general, AI, again, I'm a tech guy. My last startup where I was a co-founder was an actual AI company. We tried very hard and still going on to help people in recruitment business to apply AI to improve diversity, and it's a little bit of like difficult use case to explain, but basically we applied AI to help people get recruited in a more fair way. So we were tapping into video and transcription and trying to extract insight and analysis and using AI to shorten those footage and decision-making processes. So everybody's actually saving time, right? Like an interview doesn't have to be 40 times 1 hour recordings.
Sure.
It was an interesting use case. I'm actually pretty excited about AI, but mostly AGI. And I heard today the former OpenAI chief scientist, Ilya, just announced a new AI company. I just read it on Twitter. I'm pretty excited about AI as is now. ChatGPT can't even write a poem. Don't tell my wife, hopefully. But I asked ChatGPT to write a poem for her on her birthday, and it did a great job, honestly. I changed it a little bit just in case I don't get caught. I am very, very excited about AGI when the AI gets to the point where it can act like a human and is capable, or is sentient. I think world will change. I will almost like say this, Turing machine computers change the world. AGI will change the world, in my opinion. And even now, the typical AI is changing the world. Like, I don't buy the hype where a lot of people think like, oh, it can only do like very tedious secretary work. That's not correct. There is a lot of technology behind the scene, accessible to give us hope to change the world. That includes autonomous cars. That includes, like solving very complex diseases. I know a lot of AI models are being used in the cancer research. Some of my friends actually work there. So it's unlocking a lot of value that would take like human almost like generations. My concern is about fair application and the safe application, but I know it's a general concern. Again, Ilya made an announcement today. I think his company is called something like Safe.
Interesting. Yeah.
It's not a hype, it's a reality. Don't be one of those people that deny the technology. Sure, you can write a poem like I did. You can generate a song. That's the fun part. AI is not done. Like in 10 years, 20 years, world will be a very different place, in my opinion.
Yeah, totally agree. So like maybe just wrapping some of the stuff up and thinking about, obviously you mentioned you use us, which is great, but how do you choose a vendor? How do you choose that I'm not going to go and run this myself? I'm not going to, because clearly MQTT, many options there. Kafka, many options. We talked about that, time series databases. But yeah, maybe as a general point, how do you choose a vendor?
Yeah. Number one is requirement. So I think it's fair to mention that I procured thousands of software in my career in 25 years. HiveMQ is just one of them. The number one is requirements. The product that I'm buying or I'm getting has to check maybe all, if not most, of the requirements. That's number one. Like, and I usually check the boxes, and then I look at, this is my personal order. I look at the reliability. Is that product reliable? I like to get a trial. I like to talk to customer or a few customers if I can do. Once I see, okay, this product is reliable and it's going to work all the time, then I look at the cost. Obviously, if it's not something I can afford, or as I scale, if it's going to break the bank, I just can't, like take it. The fourth one, this is my, again, favorite one, support. If every product or partner, the way I like to call, you will need support at some point, especially if you're serious about it, if you're going to scale about it. I actually met HiveMQ on this topic. Obviously, when I decided on the MQTT, I called IBM. They got back to me in 40 days. This is no joke. They're like, again, I'm in Los Angeles.
Yeah.
Based in Los Angeles, and their team from Canada got back to me in 40, actually it was like 41 days or something. And I'm like, okay, this can't happen. So I'm Googling around and I came up with HiveMQ. I just called Cole, your CEO. I don't know how I found it, or LinkedIn. And again, time zone difference, right? I probably messaged about 4 p.m. At my midnight, I got a message. Hey, this is my cell number. When can we talk? That's how I met you. Since then, honestly, your support and the quality of support, but also the responsiveness of support is what makes me call HiveMQ a partner. And again, for the audience, this is the second time I'm becoming a customer. I'm a paid customer, and just to let you know, HiveMQ is not paying me anything to say these things, but I like.
We should have started the whole pitch of this, so that's true. Yeah, that's not.
And the longevity. Like this is actually something I really care about as well. Like, for example, you cannot pay me enough right now for me to use Terraform. Now, tech people know why. Because they got acquired by IBM, and God knows what's going to happen to them. I look at the longevity. I like to talk to people. I ask this question to Timescale. I asked this question in Flux back in days. You name it. Like, I work with Avon. They have a great, actually, Kafka offering. If you guys want to use Kafka really quick, Avon is a Confluent, but I prefer Avon. Longevity, don't be shy to ask, hey, okay. A good example was lenses.io. They have a great product. They got acquired, and they just disappeared. In fact, I had recommended them to a few people. One of my friends couldn't get a response for 3 months. This is no joke.
Wow.
I think now it's settled. Just be careful, because some companies, when you're just about to scale, they will get acquired or they will get bankrupt. They won't be able to raise money. So longevity of the company is pretty important. And the last thing, obviously, this is rare, but I usually ask for a roadmap. I may have asked HiveMQ like 100 times. Hey, when are you going to release this Kafka extension? Hey, why don't you build this like Kubernetes-based one? And, you guys were fair. And in many times, your CTO actually hopped into a call with me, maybe 3 times during my Flow tenure, 3 years. And he guided us, or my architects. Hey, Cihan, have you considered this or this or this? Like, again, I asked about MQTT Ascend to Christian, your CEO. He told me your private roadmap. Hey, now, now I'm going to go ask him, hey, is this implemented? Like, can I just use it in the next 3 months? So this is my personal list. Again, you can choose, but requirement and reliability must to have, obviously, for everybody. Support, cost, efficiency, support, and longevity, I would say.
This question came up, and you don't have to answer it. I'll ask it, but you can defer it, right? So why aren't you using InfluxDB anymore? Do you want to answer that, or should we defer it?
Sure. Okay. I mean, there's a very fair question. I like to use the best products. InfluxDB went through a few tough decisions. I actually literally went to their InfluxDB days in San Francisco, so I have a good relationship. There's nothing wrong with them. In my opinion, Timescale is a much, much, much superior product, and it was built by a much better team. When I met Timescale people, actually person, their CEO, it was in IoT World 2017, 18 in Santa Clara. It was this tiny booth. But when I saw the product, I'm like, okay, this product will just go and, be a much better product. So I didn't just jump. Again, InfluxDB went through this their query language was different, and then they came with something else, Flux, I think, and SQL. There was a lot of migration, and there was high cardinality problems. But the main reason, again, that was not on InfluxDB.
Yeah.
Like, engineers know SQL by heart. In my opinion, that's the most like, it's my love language, I would say. Like, learning time scale, like for my entire team of maybe 15 engineers, this is no joke, half a day. And we could migrate in 2 days. And we use Postgres, the power of Postgres and the extensions. It's just like, for me at least, it was no-brainer. I haven't followed Influx. I'm sure they're still a great product. Everybody should list their requirements and approach, but in my opinion, nothing beats Postgres ecosystem. It's so powerful. Also think about hiring and training, right? Like any engineer you hire these days will have Postgres experience. If not, they will have SQL experience. Learning curve is just like this. And remember, I'm in the game of pace.
Yep.
So if I'm going to spend 3 months for training an engineer versus 2 days, that's a no-brainer decision for me.
Awesome. So we're going to get to if you have questions, put them in the chat. We'll get to those. I one last question, Cihan, and it's just more maybe of a wrap up in terms of, you talked about, maybe your PDD, principal design development. Love that. But what's your one bit of advice for an architect sitting in this going, okay, I have similar problems. Maybe I'm not in water, but I'm still have remote monitoring problems. So what advice would you want to leave with the audience?
Yeah. I would say don't get paralyzed. This is like playing chess, right? You have to play the game to think about the move at 40th move or 30th move. Don't chase perfection and go step by step. You can iterate on a lot of things. However, you got to get a few things right, and I'll just count them. Okay. Get your protocol right. In this case, if you're going to use MQTT, just make sure that's a good protocol for you. The second, get your security fundamentals right. Adding security to a bad architecture is insanely difficult. In fact, it's gonna probably create a redo or vulnerabilities. You have to decide, how you pass the data. And the third, this is a little bit more on the hardware side, but choose your hardware carefully. You can iterate on the software, you cannot iterate on the hardware, and design for failure. No matter what you do, your network will fail, your hardware will fail, your software will fail. If you're just relying on everything working 100%, you're going to 100% fail in IoT. Mark my words on that. That's what I call it, principle-driven development. Again, get your communication protocol right, get your security model right. Even though you don't have to implement it, you have to. And a quick practical advice, if you can, I hate passwords. In my opinion, even before AI revolution, we have to do a password revolution. Everybody should stop using passwords. Everybody should move to passkeys, meaning use cryptography, right? And that problem is not, we don't have a problem until quantum computers become available, that cryptography is resolved, but that's a massive problem. Implement your security model, if you can, implement a public key infrastructure using client certificates with cryptography, because you're going to use a username and password on MQTT, and guess what? How are you going to deploy it to your every sensor? If you deploy every user, if your username and password is not unique, well, guess what? One of them will be hacked, and you're going to have a massive problem. I'm sure you guys heard of this baby monitor being hacked, doorbells. Same problem. So when I implemented public key infrastructure, obviously we didn't go to DigiCert. Well, I asked, they said $800,000. My team implemented it in 2 days. In fact, now there are amazing public key infrastructure using cryptography. Small Step is one of them. There's one on the Java side, EGBCA, I guess. But on API, most of the IoT architects here need to implement and integrate with their manufacturing processes. Just be careful. If you're using China, this is a very hypothetical situation, but US elections always affect tariffs. integrations. For those who have not been to China, Google is blocked. If you're using GCP, good luck, right? So there's a lot of practical approach, but don't leave security to the last minute. You're going to fail. In fact, a very practical approach, when you raise money or when you do diligence, they are going to rip you apart if your security is not on par. And I will say, use a reliable MQTT broker. I would not use, I've seen this, I advise to a lot of startups. Nothing against Mosquito. I love the guys behind it. I use Paho, but they just put a Mosquito broker, because if you Google it, it's going to come first, right? It's just setting it up is like 2 minutes.
Yeah.
It's not secured. It's not cluster. Remember what I said. Your MQTT broker is what's going to make or break you. That's your number one touch point for your sensors. If you lose your MQTT broker, you're losing your connectivity. You're done. And last practical tip, I think this is the last one. Don't wait to implement your over-the-air updates. That's part of your product. In fact, when I see people not thinking about their over-the-air updates as the first thing, I immediately like to think like, okay, this person has no idea about IoT. Like your CI/CD in your cloud, you have to set up your OTA and make sure your success rate is about 99%. Your product can be awesome. It could be amazing. If you cannot release code to your, update the firmware to your sensors, you're done. You're done. You can, unless you have this like military application, right? You're going to send a commandos parachuting into your ship and updating USB. I don't think that's the case.
Little expensive, yeah.
And don't implement your OTA, guys. I've done those mistakes. There are a lot of amazing OTA frameworks. Like from the top of my head, like Mender is one of them. Goliath is one of them. Depends on if you're using like a Linux, RTOS. Maybe one more I can squeeze. That's another like hard-learned lesson.
Yeah.
Keep your binary size as low as possible. Like I've seen a lot of people just choosing a Linux distribution just because you can run a full like Ubuntu distribution in your connected device doesn't mean you should run it. There are like there's things like Yocto, for example. You can just go choose this package, that package, right? Customize it. We could actually reduce at flow. Now we have our binaries are very low because we are more experienced, but at flow, I think we started from 600 megabytes. We reduced it to like almost like I believe it was like 4 megabytes or 5 megabytes.
Yeah.
It increases your success rate quite a bit. So yeah, those are like critical things.
Excellent. Well, appreciate your time, Cihan. I know we're sort of wrapping up here. I'm going to pass it back to Anadelia, but I wanted to at least thank you so much for sharing this stuff with you. And Anadelia, yeah, what's the next steps? How do people get access to all these cool stuff that we talked about?
Yes, absolutely. Thank you all for joining us today. If we did not get to your questions, we will be following up with you via email. You will also receive the link to the recording of today's session. And once again, thank you so much to our speakers for joining us today, and we will see you at the next one.
Great. Thanks all.
Thank
Bye-bye.
you.